Hi guys, today I want to share my thoughts on the puzzling scoop marks at the ancient Aswan Quarry in Egypt, where the world-famous unfinished obelisk lies. This obelisk is the largest and heaviest of all, a massive single piece of red granite, measuring 42 meters, 138 feet in length, and estimated to weigh 1,200 tons, or 2.6 million pounds. It's said that a crack formed during the cutting process, so the masons abandoned the project, leaving the almost finished obelisk still attached to the bedrock at the bottom. As we see, there are intriguing excavating tool marks, the so-called scoop marks on the obelisk and other areas of the quarry. It appears that the granite was softened like butter and scooped out with a shovel. These scoop marks are so distinct and unusual that they have been in the center of debate for a long time. Till today, nobody knows for sure what caused the scoop marks around the unfinished obelisk. Mainstream archaeologists claim these markings came from workers pounding dolorite stone balls. Christopher Dunn suggests it was a machine with a pivoting arm that could scoop under the obelisk. Brian Foster thinks it was vibrational technology. By the way, there are other ancient Egyptian sites with similar scoop marks. Inside the Great Pyramid, these marks showed up on the granite beams in a relieving chamber. On the west bank of the Nile, there is a quartzite quarry exhibiting the same scoop marks. Quartzite is another hard rock, composed of over 90% of quartz. Why do we only see scoop marks on these hard, quartz-containing stones? Was the granite softened? What caused the scoop marks? In this video, I'll share my thoughts and discuss the following 3 topics. 1. Could the granite have been soft and malleable? If so, would that be the reason of the scoop marks? 2. Through observing the shared feature between the ancient Aswan quarry and the modern quarries, and then compare the excavation marks on stone surfaces produced by various stone extracting methods, my hypothesis on what could be the most plausible answer to the scoop marks. And 3. Why the unfinished obelisk is evidence of lost ancient high technology from an earlier unknown civilization and not created by ancient Egyptians pounding dolorite balls. Let's get started. The granite of the Aswan quarry is characterized by a rose color and large-sized crystals, and has been actively mined throughout history. Ancient Egyptians, Romans, and Arabs all have been recorded in this area and possibly left their own excavation marks at different times. Besides the scoop marks, there are chisel marks, 5 cm wide wedge holes left by the feather and wedge method, and a type of smaller wedge holes which might have been from the Arab mining activity. The Aswan granite outcrop has natural faults, which are highlighted in red lines. The unfinished obelisk is carved out in line with the orientation of the natural faults in the bedrock, indicating that the obelisk cutters understood geological conditions and made the best use of the rock. Now, could the granite have been softened so it could be scooped out, shaped, or manipulated like clay? Can frequencies or heat do that? Specific frequencies, especially ultrasonic or vibrational energy, can assist in softening or weakening granite, but not in the sense of making it soft like clay. Instead, these techniques reduce granite's resistance to cutting or breaking. Ultrasonic drilling or piezoelectric drilling creates micro cracks in granite through a process called piezoelectric excitation, which involves applying high-frequency, high-voltage alternating current to the quartz within the granite. This weakens the rock's overall strength, thus improves drillability. However, frequency does not literally make granite soft like metal at high temperatures, and it cannot reshape granite plastically. It only facilitates brittle deformation to break down rock. On the other hand, heat can soften or even melt rocks. If a rock is heated above its brittle to ductile transition temperature, for granite, the transition typically occurs at temperatures around 400 to 800 degrees Celsius. It will react with ductile deformation or melting. At temperatures below this range, granite exhibits brittle behavior, while in a ductile regime, granite begins to behave plastically or ductilely under confining pressure. Confining pressure is the pressure or stress exerted on a material uniformly from all directions, like those found deep underground. In the lower crust, where pressure is high and temperatures can reach 600 to 900 degrees Celsius, granite can flow slowly over time. But at the surface of the Earth, where the pressure is low, granite does not behave ductilely even at high temperatures. It's more likely to crack or melt. So, granite can only reach a ductile state at the right temperatures and confining pressures. For industrial purposes, heating granite to ductile conditions is not practical. It takes extreme energy and still deforms slowly. Even if the super tricky and costly heat and pressure conditions can be achieved, there is still a big hurdle to slowly cool the softened rock back to its original granite state. Granite forms as magma cools slowly beneath the Earth's surface, where the slow cooling allows relatively large crystals to have time to form. If the ductile material is cooled less slowly, say cooled in air, the mineral crystals within it would be much smaller, perhaps predominantly very small, and thus the end product would not be the same Aswan granite with the large-sized crystals, but a different rock with different textures and mineral arrangement. Therefore, softening granite to a ductile state using either frequencies or heat for quarry purpose would not work in any practical sense. This means although the scoop marks around the unfinished obelisk might look like the stone had been soft and scooped, in reality, it's mission impossible. Also, despite the prevalence of scoop marks at Aswan Quarry, there is no scooped granite lying around. Was rock actually scooped or broken down by a tool that left scoop-shaped trails? What quarrying method could leave these unique markings on granite? Let's observe the scoop marks. On and near the unfinished obelisk, there are areas of multiple indented squares, or scoop marks, that are like a strange chessboard. These scoop marks have similar dimensions of 40 by 40 centimeters, which could be the size of the tool used to excavate granite here. At other places, the scoop marks have rounded and curved edges. Could the tools have had multiple shaped cutting heads, some square and others round or curved? The surfaces are slightly rough and uneven, which contributed to the scoop look, instead of a saw-cut appearance. In most areas, the cutting is not perfect or straight, but somewhat curved and angled. A narrow corridor or trench was carved around the obelisk, with an average width of 75 centimeters. Scoop marks on both sides of the corridor present as vertical bands going down, then curved at the bottom and continue to go around and under the obelisk. These vertical bands are also about 40 centimeters wide. The rock underneath the obelisk had been cut out from both sides, and only a narrow central portion left attaching the block to the bedrock. These vertical scoop excavation marks lead to the second topic. They, in a way, are a shared feature with the modern quarries, and that can help us better understand the ancient quarrying method. Before jumping into this, I want to show you another area of the quarry, where there are curved scoop marks on both sides and a severed granite stripe in the center. I think there might have been a block or obelisk excavated with the scoop method on top, which was attached to the bedrock at the narrow bottom, just like the unfinished obelisk. The smaller obelisk or block was severed from the attached bottom and transported somewhere else. The unfinished obelisk is a massive piece, the biggest of all. Before carving the biggest and heaviest obelisk, the masons must have started from making smaller ones first. Open quarries are mined from top down. The unfinished obelisk is embedded in the middle of the bedrock. This signifies tons of granite have been excavated and removed before reaching to the location where the unfinished obelisk lies. It's logical to propose that the masons started quarrying smaller obelisks utilizing the scoop-like method at the upper quarry, and finally began their most ambitious endeavor after finessed their techniques. If there was another granite obelisk excavated with scoop marks and shipped away, that implies that there could be more of them. Worldwide, by estimation, there are around 28 Egyptian obelisks made of Aswan granite. How many of them were quarried with the scoop marks, I wonder? Okay, back to the shared feature between Aswan and modern quarries. The striped vertical scoop marks at Aswan resemble a common modern excavating process, which consists of separating large blocks from surrounding rock using vertical top-down techniques. These techniques, such as blasting, line drilling, and jet flame channeling, could also leave vertical patterns on the sides of the excavated rock. These activities are the initial step in quarrying, breaking down the rock before it's further processed and transported. The blasting method involved drilling holes into the rock, loading them with explosives, and detonating them in a controlled manner. These vertical marks are relatively sparsely or unevenly placed and don't need to be drilled all the way down. Hence, the blasting method does not fit well with the Aswan scoop marks. Here are photos of line drilling technique in granite. The left shows drilling of contact holes to separate a stone block. The circular drilled holes overlap each other and produce curved ridges and a corrugated pattern. The right is the granite quarry face with evenly spaced vertical drilled lines. Could the bands of the vertical scoop marks at Aswan have been generated the same way as the modern line drilling? But the scoop marks are 40 centimeters or 1.3 feet wide, much bigger than the current largest granite drill bits. They are not as smooth or consistent as the circular drilled faces, and the scooped rock surfaces can be uneven, patchy, and bumpy. Plus, the scoop marks can curve and change angles during the excavation process. The chessboard-like scoop marks show that these ancient tools did not make uniform, round drilled holes with noticeable edges, but instead are all at a slightly varied depth with buffered, raised, and non-precise edges, which created the signature Aswan scoop look. What kind of drill can do that? These characteristics makes me think that the drilling which left scoop drills was neither mechanical nor precise. As advanced as it was, the tool was used as the first step to rough shaping and separating the stone blocks from the surrounding bedrock, but not for more precise cutting and detailing. It's time to check out the third drilling technique that could generate a different type of vertical patterns on cut rock faces. Jet channeling, also called flame jet channeling or torch cutting. It can make continuous deep cuts to free large blocks from granite formations. Jet channeling made its entry into the granite industry in the 1950s and quickly gained acceptance as an economical method of quarrying. During that time, the channeling method employed a small rocket jack burner with a high-temperature, high-velocity flame around 2500 to 3000 degrees Celsius that causes the granite surface to disintegrate. Such devices can be handheld or machine-mounted, and can drill a channel up to 6 meters deep. Here is a photo of a worker lowering the flame vertically to drill through granite, similar to using a mechanical drill for line drilling. The intense heat causes thermal spalling, where the rock surface layers flake off due to differential expansion and stress, and result in a relatively smooth, yet textured, rougher, and less artificial finish. Since the flame from the drill head is localized, the heat would not do much damage to the integrity of the granite block. Here is footage from a National Geographic program showing a flame jet drilling model with a bigger diameter. The flame came out of the drill bit, cut through stone like butter. Tiny fragments of rock flaked off, and formed a 10 inches deep, 4 inches diameter hole in granite in about 3 minutes, which is impressive as it works faster than diamond drills. If such a flame jet machine can be scaled up from 4 inches, 10 centimeters, to 40 centimeters drilling width, and do touching or overlapping vertical drills like line drilling, then you might be able to generate similar striped scoop mark bands seen at the unfinished obelisk. Remember that these perplexing scoop marks only show up on hard, quartz-containing stones like granite and quartzite. An interesting fact about flame drilling is that it's a specialized method, highly efficient for creating holes and cavities in quartz-rich hard rocks, such as granite that is difficult to drill using traditional methods. But it does not work well with rocks that do not readily spall. For example, quartz-free rocks like limestone and dolomite, because its effectiveness relies heavily on specific mineral properties, particularly the presence of quartz. Quartz has a high thermal conductivity and a significant thermal expansion coefficient, which contribute to effective spalling. When heated, quartz expands rapidly, generating localized stresses, especially at grain boundaries, leading to fracture. Other minerals might not exhibit the same favorable combination of thermal properties. Partially due to this limitation and more wasted material, the jet channeling method was later replaced in the United States by more versatile and precise diamond saws and diamond wires, though it might have a comeback. In 2021, a company named Petra unveiled the first non-contact thermal drilling technology for utility tunnels to bore through the hardest rocks in the world. Petra's semi-autonomous robotic system is capable of boring a range of diameters between 20 to 60 inches, over 50 to 150 centimeters through any geology. Aswan scoop marks are 40 centimeters wide. The trench around the unfinished obelisk is averaging 75 centimeters wide. With a 40-plus centimeter torch, it would only take 2 adjacent overlapping drills to carve out. Could ancient masons have used their version of flame jet drilling to excavate stone from Aswan Quarry? I think the process might have been like this. In an area free of faults, according to the pre-designed obelisk shape, vertically lower a torch of 40-plus centimeter in diameter to drill a line of overlapping holes into the granite, which would produce vertical patterns with ridges in between on the future obelisk body. Once the outline of the obelisk and the initial separation from the surrounding rock is done, offset the torch outwards slightly less than 40 centimeters from the drilled gap. Then vertically drill a second row of overlapping holes. When the torch reaches to the desirable depth, turn the torch head horizontally, or even tilt it up an angle to drill at the bottom of the obelisk to create an undercut while leaving enough rock attached to the bedrock. Do this all around the obelisk. The second row of the drills might have been done to create enough clearance to turn the drill torch to an ideal angle to cut the stone underneath the obelisk. Each drill slightly overlaps with adjacent ones, and that will generate in-between ridges. This work process is straightforward, efficient, and yields minimal waste. More importantly, it can explain the vertical excavation marks on both sides of the obelisk trench, the curved, rugged trench bottom, and the scoop marks under the obelisk. As for the dimpled, chessboard-like patterns on flat rock surfaces, they might have been testing spots, leftover torch marks when upper layer of granite got excavated, or attempts to level the stone field. Different-sized scoop marks at Aswan Quarry might come from different torch heads, some smaller, some bigger, perhaps some are square-shaped. Please note that the shape of the flame coming out of a cutting torch can vary significantly depending on the design of the nozzle or head, which would influence the flame pattern on application. The shape of the nozzle head is often a crucial factor in determining the jet's performance and its suitability for specific tasks. Round nozzles have a cone or pencil-shaped flame. Maybe that's how the scooped, curved shapes were produced at the bottom of the obelisk. The varied scoop marks at Aswan Quarry might have come from a group of torch heads. The torch could be handheld or mounted on automated jet burners depending on needs. Flame drilling can also explain the excavation of deep holes on site. These mysterious 1 to 5 meter deep holes have curved corners and free of any chisel marks. Some have horizontal scoop marks. Their depths, soft curvatures, and rather smooth finishes fit into the flame channeling's abilities. It's conceivable that the obelisk excavators drilled these holes to test lower rock quality for later quarrying work. Mainstream Egyptologists postulate that the immense unfinished obelisk with the scoop marks was made through pounding dolerite balls, since there are no traces of chisel work in the trench at all, and stone balls were found on site. Many researchers, however, argue that this primitive method is too inadequate for the excavation of the colossal obelisk. A 2023 paper studied the speed and efficiency of the dolerite pounding on granite as a quarry method. The authors found that the results achieved speak against the use of only dolerite pounders in this process and support the employment of different methods of quarrying. Furthermore, if masons used dolerite balls to excavate the unfinished obelisk, what could be the point of creating these square indents, vertical bands, and raised cuts at the trench bottom? There is no good reason to do any of that. How would these dolerite ball users lift and transport a stone product out of the quarry? The unfinished obelisk weighs approximately 1,200 tons. The second largest obelisk in the world is the Lateran Obelisk, originally incarnate from the New Kingdom. It weighed around 455 tons, and it took several decades to complete. Evidence indicates the best ancient Egyptian ships could transport up to 500 tons. Hence, the Lateran obelisk was within the feasible transportation range. But the unfinished obelisk is over 2.6 times heavier, way above the loading limit of ancient Egyptian ships. Would the dynastic architects and workers spend the time and effort to excavate a huge obelisk that they could not even move out of the quarry? Granted, there was a canal right inside the quarry, yet can a small canal float the super heavy obelisk or have enough radii to turn a 42-meter, 14-story long obelisk on a boat? This is the third topic I want to discuss, that the unfinished obelisk is beyond the capacity of ancient Egyptians, and therefore evidence of a different, unknown, high-tech civilization. Whoever had the technology and resources to excavate the unfinished obelisk must have thought about the logistics of lifting and transporting it, which signals the obelisk creators were really advanced and capable of doing so. To give you an idea on the difficulty level of lifting and maneuvering a 1,200-ton stone block, most modern cranes on average can lift loads between 11 and 66 tons. Gantry cranes can have more lifting power, yet the Aswan quarry site is uneven and may not be easy or realistic to install a big gantry crane. For a mobile crane to lift the unfinished obelisk with the current technology, we would need the strongest mobile crane on the market, the Liebherr LTM 11200 9.1, with a lifting capacity of 1,200 tons, the same as the obelisk. This mighty crane came out in 2007. If with modern technology from 2007, we finally can lift this ancient obelisk, then what did the original obelisk creators have on hand to transfer the stone out? What we see at Aswan Quarry is the leftover scene after thousands of years of excavation. A lot of clues on the scoop marks were lost because later quarrying work changed the original landscape. Even though the granite seemed to have been solved and scooped out, neither frequency nor heat would work to soften granite to a malleable state in a practical manner, and there is no scooped granite on site. The scoop markings might come from a certain drilling tool that left scoop-shaped tracks. Judging from the scoop marks' physical features, I think the mechanism behind them might be similar to modern flame cutting, which directs a high-temperature flame against the granite, causing the surface to flake off due to rapid temperature changes and thermal stresses. This method is effective for large-scale channeling on hard quartz-containing rocks, and still used in quarries to separate large blocks of granite. One last question. Do you think there are other obelisks made of Aswan granite, which were actually quarried with the scoop technology? What if the Egyptian obelisks originated from and are remnants of the last advanced civilization? If you have any insights, please leave me a comment. If you like my video, please subscribe to my channel and share with others. You can also support me on Patreon, which is a monthly charge, or on Buy Me a Coffee. I appreciate your support. This is Curious Being. I'm Tina. Thanks for watching and see you next time.